The indeterminate form of the limits of sine function is the limit of sine x over x as x approaches 0. Remember that sine 0 over 0 is equal to 0 over 0, which is an indeterminate form. But again, according to the rule of limits, the limit may exist, and that is actually equal to 0. This also means that the limit of sine x over x as x approaches 0 from the left is also equal to the limit of sine x over x as x approaches 0 from the right, and they are equal to 1. Now to start, we have limit of 3 sine x over x as x approaches 0. So the first thing we need to do here is to separate 3 so that sine x over x as x approaches 0 will become 1 in the substitution. Now multiply 3 times 1, so the limit is 3. Now in the second example, there is a negative 1 here and there is 2. So we need to factor out and bring out negative 1/2, separate it, and we now simplify limit of sine x over x as x approaches 0, and that is equal to 1. So 1 times negative 1/2 is negative 1/2. On the third example, we observe that there is 7 and there is 3 here, and x must be equal to x in the denominator. Okay, now separate 7 over 3, and by the constant multiple rule, we now simplify limit of sine x over x as x approaches 0, and that is equal to 1. Now 7 over 3 times 1 is 7 over 3. Also, we can have decimals wherein 0.012 is multiplied to sine x over x. You just need to separate that fraction and evaluate sine x over x, and this is equal to 1. So 1 times the fraction 0.012 decimal will give you 0.012 as the limit. Now, the general form of the limit of the indeterminate form of sine function is defined by the limit of sine u over u as u approaches 0 is 1. And again, we just need to take note that u can take any value or any expression. So it means that we need to have the same expression as the angle measurement and the denominator, just like this. 3x tapos 3x ito, so pareho sila. Therefore, pwede nating sabihin na let 3x be equal to u. So from x approaches 0 becomes u approaches 0 kasi we are now representing it with respect to u. And following the rule, limit of sine u over u as u approaches 0 is 1. Then we can now have 1 as our answer. On the second example, we have 7x and 7x. So as if they are now already the same, no? Regardless of not replacing that into u, and that is immediately equal to 1. On the third example, we have negative 2 here, and this is already 3x, and the denominator is already 3x. So we just need to separate negative 2, and now simplify the sine u over u as u approaches 0. Well, we just let u be equal to 3x here. So negative 2 times 1 is negative 2. On the fourth example, 9x, okay, but this is 18x. So it means to say 18x will be factored out and we separate 9x. So we just need to have 2 times 9x. That is the reason why we separated 1/2 here, because 2 is found on the denominator. Nanggaling siya sa 18x. I-separate natin ng 1/2, and we are now going to evaluate sine 9x over 9x as x approaches 0, and we can have a representation. Let u be 9x here, So that is 1. So 1/2 times 1 is 1/2. Now in the fifth example, we have x minus 2 and x minus 2 already the same. So that is as good as 1. Okay. Sine 3x over 3x minus 1. 3x minus 1. Okay, pareho na sila agad. So it is being illustrated also by sine u over u, where u is 3x minus 1. So that is equal to 1. However, on the seventh example, sine 3x over x, this is 3x. However, this is x on the denominator. So kailangan natin magkaroon ng 3 sa denominator. So kailangan natin mag-multiply ng 3 over 3 so that 3 from the fraction 3 over 3, denominator 3 will be shared sa denominator, and the numerator 3 will be separated and will become a constant. So that 3x and 3x will now be the same. Okay, so we can now just replace sine 3x over 3x as x approaches 0 into sine u over u as u approaches 0, and substitute, that is equal to 1. So 3 times 1 is 3. Also here in number 8, negative sine 2x over negative sine 12x over 2x. So kailangan natin magkaroon ng 12x. So anong kailangan ng 2x to make it 12x? We need 6. That is why we multiplied 6 over 6 here. And separating negative 1 will give us 6 over 6 times negative 1 times sine 12x over 2x as x approaches 0. Okay, so multiply negative 1 times 6, and we're going to share 6 to 2x. That's why we have 12x here, and they are now the same. Separate negative 6 by constant multiple rule. Now simplify or evaluate sine u over u, where u is 12x. So that is 1. So the limit is negative 6. On the ninth example, we have here already 7x, and this is also 7x. Now, for us to have the form wherein sine 7x is found on the numerator, denominator is 7x. Well, we need to raise 7x over sine 7x to negative 1 times negative 1. Now, this negative 1 will be shared inside so that magbabaliktad na siya agad by getting the reciprocal of it. And still, you need to raise it by negative 1. Okay, now the rule of power in limit, we will now have limit of sine 7x over 7x, and that is equal to the limit of sine u over u, where u is 7x. Substitute, that is 1. So 1 raised to negative 1 is 1. So the limit is 1. So here in number 10, there is negative 1 here. Separate that here. So 4x over sine 4x, we can now raise it to negative 1 times negative 1. Share negative 1 inside, so that will transform into sine 4x over 4x. Remember that negative 1 times negative 1 is simply 1, so there is no changes. There are no changes that will happen in that case. Therefore, we can now have the rule sine u over u as u approaches 0 will just be equal to 1. And note the signs here, negative 1 raised to negative 1. Okay, 1 raised to negative 1 is equal to 1, but there is negative sign there, so we need to follow the negative sign. So we have negative 1. Also, in number 11, we have here 2x minus 2. 2x minus 2 is factorable, so we have 2 times x minus 1. And take note that x minus 1 here and x minus 1 they're already the same. Now you raise it to negative 1 raised to negative 1 times negative 1. I-share natin ang negative 1 sa loob para makuha ang reciprocal na ito. And we can now evaluate the limit. So the limit is just equal to 1. So 1 raised to negative 1 is 1. So 2 times 1 is simply 2. So the limit is 2. Next example, we have x squared here. So in that x squared, we are going to separate the other x. Okay, so we just have this. However, we need to have 5. That is why we multiplied 5 over 5 by sharing 5 here. Okay, so we now have 1/5 x times limit of 5x over sine 5x, and that will be 1/5 x. Again, raise that to negative 1 here. So we now have simply 1 for limit of sine u over u, but this is 0, therefore the entire product is 0. For sine function, sine x over x, okay, sine x over x as x approaches 0 is 1. That is for sine. However, for cosine, 1 minus cosine x over x is 0. Well, we can check the left and right. Both approaches 0. They get closer to 0. Now these are special limits. So we now proceed to the special limit of cosine function. Now, according to the rule, limit of 1 minus cosine x over x as x approaches 0 is simply 0. Well, that is according to the graph also, that when you go to the left or to the right of 0, or to the left of 0, then y approaches 0. Okay, now let's have the first example. Again, it also follows that the left and right are equal and they're both equal to 0. So number 1, limit of 1 minus cosine x over 2x as x approaches 0. Okay, we need to separate 2 here kasi kung x ito, dapat x lang din ang maiwan dyan. So that we are ready for the substitution here. And again, that is all immediately equal to 0 and multiply 1/2 to 0. The answer is 0. Now, the second example, we can separate x here, factor it out. So, ano naiwan? 1 minus cosine x. So, itong 1 minus cosine x, limit of 1 minus cosine x over x as x approaches 0 is simply 0. Okay? Now, let x be equal to 0. So, 0 times 0. That is 0. Now, in the general rule, the limit of the indeterminate form of cosine function, special limit, is defined by limit of 1 minus cosine u over u as u approaches 0, and that is equal to 0. Okay, again and again, you just need to first observe whether the given function becomes indeterminate at a given value of c. Okay, so in this case, these are all indeterminate. Now here, limit of 1 minus cosine 5x over 2x as x approaches 0. This is 5x. However, this is 2x. So, kailangan natin magkaroon ng 5x. Kaya tayo magmumultiply ng 5 over 5 at i-separate natin ng 1/2. So, we need to factor out 2x and bring out 2. Okay? Now, you need to share 5 here so that you have this form, 1 minus cosine 5x over 5x. And you separated the constant 5 over 2. Now substitute, we let u be 5x. So this is simply 0. So 5 over 2 times 0 is 0. Second example, limit of 3 minus 3 cosine 10x over 5x as x approaches 0. This is 10x, but this is only 5x. So we need to multiply 2 to the denominator and multiply 2 over 2 both numerator and denominator to have no effect at all. Okay, so share 2 to 5x, so we have 10x. Now 2 times 3 is 6. So you now have 1 minus cosine 10x over 10x, where u is equal to 10x here. Now this will become 0. So 6 times 0 is 0. Okay, we just have to assume values. Both numerator and denominator must be equal. Multiply them, share, to be able to form the needed expression. So in number 3, 7x and 7x, pareho na sila, so that is good as 0 immediately. However, you have limit of identity and limit of constant. So limit of x as x approaches 0. Here we expanded using the addition rule or subtraction rule. So limit of -2 as x approaches 0 is simply -2. So 0 plus 0 minus -2 is 2. So that is the limit. Now in number 4, we have here 2 minus 2 cosine 3x. So 3x and 3x already the same. So we just need to factor out. So 2 is brought out. That is a factor of 2 minus 2 cosine 3x. Okay, plus limit of 5 as x approaches 0. That is constant. So 1 minus cosine 3x over 3x as x approaches 0 when it comes to limit is simply 0. So 2 times 0 is 0. So 0 plus 5 is 5. Okay, so here 3x, walang problema kasi pareho na ang numerator and denominator, the angle and the denominator. Now number 5, we can factor it out and we bring out -4. Okay, so -4 times 1 is -4. -4 times negative cosine x cubed is +4 cosine x cubed. And x cubed already the same, numerator, denominator, plus limit of 1, which is a constant. Okay, we can now substitute. Let u be equal to x cubed. So according to the rule, that is simply 0. So -4 times 0 is 0. Added to 1, the answer is 1. Now, what about in the indeterminate form of tangent function? So if you try to consider the graph of f of x is equal to tangent x over x, we can observe that as x approaches 0 from left or right, y gets closer and closer to 1. Now, according to the rule, and if we try to verify or prove the indeterminate form rule, that is limit of tangent x over x as x approaches 0 is equal to 1, we can go back to the reciprocal identity or ratio identity of tangent x. So let us prove. Limit of tangent x over x as x approaches 0 is equal to limit of tangent x times 1 over x as x approaches 0. We just factored out, okay, tangent x times x is tangent x times 1 over x. Now we substitute tangent x into sine x over cosine x. Remember, that is the ratio identity of tangent. Now we follow the expression sine x over x. That is why x here is being shared. However, cosine x is moved to 1 over cosine x. And x is moved to the denominator of sine x over x. To make it equal to 1, so this is immediately equal to 1. Sine x over x. Well, that is the rule for sine limit. However, for limit of 1 over cosine 0 is 1. Okay? And since cosine 0 is 1, so 1 divided by 1 is 1. 1 times 1 is equal to 1. So, well, that is the reason why tangent x over x as x approaches 0 is simply equal to 1. Now, that is also a special limit. So, limit of tangent x as x approaches 0 from the left is equal to 1, which is also equal to limit of tangent x over x as x approaches 0 from the right. Okay, let's have an example. So here, we can separate 3 so that tangent x over x as one quantity can now be expressed into a single value, 1. So 3 times 1 is 1. Another, if we have negative sign here, it is understood that there is -1. Now we separate 2 on the denominator and be able to have only tangent x over x. So that will be negative 1/2 times the limit of tangent x over x. As x approaches 0, the limit is negative 1/2. Just simply substitute tangent x over x. It will become 1. On the third example, 7 over 3 can be separated, so that tangent x over x will now be evaluated. And that is simply equal to 1 according to the rule. So 7 over 3 times 1 is 7 over 3. Now we have here a fraction 0.012. Separate that and evaluate the function tangent x over x as x approaches 0. Get the limit. That is simply 1. That's the rule. So multiply that to the decimal 0.012. The answer is 0.012. Now in general, the limit of the indeterminate form of tangent function is defined by the limit of tangent u over u as u approaches 0 is equal to 1. Again, u is any expression. Okay, we just need to have the same expression here so that we can now have the final answer 1. Let us observe the first. Here, this is 3x and 3x. They are already the same. Therefore, that can now be immediately 1. Even if we don't need to, even if you will not rewrite that into u that is equal to 3x. Okay, since they're already the same, then you can now have 1. And so with this, that they are the same. That is tangent 7x over 7x. That is 1. Now number 3, we can now separate negative 2. Why? Because 3x also have 3x. So this is simply 1. So negative 2 times 1 is negative 2. In number 4, this is 9x, but 18x has factors 9x times 2. So it is good as removing 2 on the denominator, separate it, so that you have tangent x over 9x, where 9x is a factor of 18x. Now separate 1/2 and multiply that to the limit of tangent 9x over 9x as x approaches 0. So this will be 1 according to the rule. So 1/2 times 1 is 1/2. On the fifth example, x minus 4 and x minus 4, they're already the same. That is simply equal to 1. And so with number 6, that is also 1. You see, if they are the same, the angle of the tangent and the expression on the denominator are the same, then they can then just be written as 1. Okay, but in the case of number 7 and other examples, we are now getting numbers to satisfy the condition. So kung 3x ito, kailangan natin magkaroon ng 3x sa denominator. And nakikita natin na x lang ito. That is why we need to multiply 3 over 3 so that 3 on the denominator will be shared to x to have 3x, and they're now the same. Now separate 3 and that will become a constant. Evaluate tangent 3x over 3x as x approaches 0. And that is also tangent u over u as u approaches 0 if you would like to substitute. So 3 times 1 is already 3. Now, negative tangent 12x over 2x. Negative, so that is negative 1. But 2x needs 6 to have 12x. That is the reason why we have 6 over 6 here. Now, share 6 on the denominator to have 12x. And multiply all constants and separate them. So you have negative 6 times limit of tangent 12x over 12x as x approaches 0. They now have the same number, 12x. So that is already 1. That's the rule. So negative 1 times 1, negative 6 times 1 is negative 6. Here we have 7x and 7x. So you just need again to have or to raise that into to 1. However, you need to have negative. So negative 1 times negative 1 is simply 1. Now, place negative 1 inside. Simplify that inside so that you now have this expression, okay? Para magbaliktad na siya at magpakita yung tamang itsura niya para hindi kayo malito. So you have tangent 7x over 7x. And they are both 7x. So that is simply 1. So 1 raised to negative 1 is 1. On number 8, you can do the same. However, you need to separate negative 1 here. So negative 1 is the answer. Okay? Here, factor out. So 2 times x minus 1. So here, x minus 1 and x minus 1 here already the same. But you already separated 2 here. Hiwalay mo ang 2 kasi hindi na siya kailangan. And that 2 will be part of the, what we call the constant. So 2 times the limit of x minus 1 over tangent x minus 1 can be, you can get the reciprocal by raising it to negative 1 and again raising it to negative 1. Para negative 1 times negative 1 is again 1, so walang epekto. So 1 raised to negative 1 is simply 1, so there's no problem. 2 times 1 is 2. Now here in number 12, limit of x raised to 2 over tangent 5x as x approaches 0. 5x kasi ito. X squared ito. Pero x lang yan, 5x, a single x. So we need to separate 1x on the numerator. We need to assume 5 over 5 so that we can have the same number 5x. Now share 5 on the denominator. On the numerator, kaya nandito 5x. Now separate all the unnecessary factors. Simplify by raising it to negative 1 times negative 1. Okay, that is already equal to 1 according to the rule. So 1/5 times 0, because let x be equal to 0, times 1 is 0. Okay, now after exploring the 4 basic indeterminate forms, we can now combine them, just like this in number 1. Sine x over e raised to x minus 1. So you have the idea to form sine x over x and e raised to x minus 1 over x. And this is x squared. So pwede siya mag-separate into x times x. So e raised to x minus 1 over x times sine x over x. As x approaches 0, so ito, magiging ln of e yan, which is equal to 1. This is automatically 1. So 1 times 1 is 1. On number 2, square ito. So can be written into sine x over x squared. So parang nag-factor out ka lang dyan. Sine x over x squared. Okay? So a non-separated factor, it is 1 over cosine x. Now, sine x over x is simply 1. So 1 raised to 2 is 1. So cosine 0 is 1. So 1 over 1 is 1. 1 times 1 is 1. On the third example, sine 5x over sine 4x. In this case, we need to have a form sine u over u. That is the reason why we multiplied or we divided x, numerator and denominator. After that, if this is 5, we need to multiply 5 over 5 numerator. 4, so we have 4 over 4. So that when we separate 5 here and we separate 4 here, then we can now able to have sine u over u. That is the main intention. Now, the constants 5 and 4 will be separated. Now, evaluate the other. No problem, that is only equal to 1. Okay, do not be confused by w and u. Those are just representations. Bear in mind that if you have the same number as the angle in the denominator, that is simply equal to 1 in the limit notation, in the indeterminate notation. Okay, so 5 over 4 constant multiplied to 1 is 5 over 4. The fourth example, 1 minus cosine 3x over sine 7x. Okay, in this case, we are forming 1 over cosine x over x, or that is u over u. So that, to be able to have that, you need to divide both sides, or the numerator and denominator, by x. Okay, now following 3x here, we need to assume 3 over 3. 7x, 7 over 7. Now share 3, denominator, share 7, denominator. So after having that, you see, now separate the constants. And as observed, pareho na sila. Okay, now substitute. Since 1 over cosine u is 0, so the numerator is 0, while the denominator is 7, so 0 over 7 is 0. Now on the fifth example, sine 3x over tangent 5x. Sine x over x is 1 when it comes to limit. That is also equal to the limit of tangent x over x as x approaches 0. So they do the same, okay? So here we can just immediately have 3x over 3x, 5x over 5x. So that we can now have 3x on the numerator, 5x on the denominator. This is already 1. This is also 1. But x and x here can now be removed, no? Pwede na siyang i-eliminate. So ano ang natira? So we have 3/5 here. Okay? And sine u, tangent w, do not be confused by this, and those are just representations. Hindi kasi natin pwedeng gamitin ang u at the same time. Because 3x and 5x, ay hindi naman sila pareho. Okay? So, we need to have another representation that is w, but wala naman siyang malaking epekto sa proseso. Okay? So here, substitute limit of sine u over u as u approaches 0. That is 1. And the limit of tangent w over w as w approaches 0 is also 1. So 3 times 1 is 3, 5 times 1 is 5, 3 divided by 5 is the fraction 3/5. Now, you will just remember that in sine u over u, ang ibig sabihin lang nito, kailangan pareho yung angle, expression ng angle at saka yung expression sa denominator. That is also true kay cosine. So 1 over cosine u over u, the angle and the expression must be the same. For tangent, the same also. Okay. Now, if they are not the same, so let's say, again, if you say you have sine 2x, then this is x. That is the time for you to assume, okay, have a number that is 2 over 2, so that 2 is separate, is, okay, shared to x there to be able to have 2x over 2x. So, anong natira? 2. Well, paulit-ulit lang naman na ganun ang gagawin nyo when you are solving these special limits. You just need to be very careful. And again, the first thing you need to do is to test if it is 0 over 0 form. If it is not 0 over 0 form, then the direct substitution cannot be used. But if it is 0 over 0, then that's the time for you to look into the special limits.